All right, so we're looking at the following deformation mechanism map below. Comes from a curve that looks like this. Label the sections of the deformation mechanism maps. So theoretical stress, dislocation glide, elastic region, PLC, power law creep, Coble creep, Navarre-Herring creep. Excellent. I take this material, initial grain size of this, cold roll to reduce the grain size of this, draw the stress strain curve in figure 7, and draw how the map will change. So I take this material and I reduce it. So actually I'm going to have it's going to look exactly like this. Same Young's modulus, higher yield stress, and then it'll fracture earlier. So strain at fracture is more significant. So, and if I draw how the stress strain curves will change, or the deformation mechanism maps, I'm going to increase this line here. It's going to get higher. My yield stress curve gets higher, and this region, the Coble region, gets larger. And we can obviously do that basically based on the Coble creep mechanism. Change in yield stress here scales as dislocation density to the 1/2 power, and it scales as my grain size to the -1 power. Now I take the material and add a solute. Draw how it changes now. So if I add a solute, now my Young's modulus actually changes. So my Young's modulus gets slightly higher here, and then yield stress, and then it fractures. If I were to draw this, same change here. So my yield stress would get higher than my original curve here, but this region would no longer change. So everything else would be the same, it'd just be this line moves up. So there would be no change in that Coble creeper region, as we've discussed a lot in class. Relevant mechanisms here, change in yield stress scales as concentration of solute to the 1/2 power. Why is creep such a dangerous yielding mechanism? Why is it so difficult to predict, such a design against? The whole idea is material yields, my material will yield at stresses. So when I apply a stress that is basically much, much less or less than my yield stress, the material actually yields. So it's very, very difficult to predict. There's a lot of kinetics that get involved in this as well. And that's kind of the idea. That's the concept. All right, and that's it. That's your exam. So we'll see you next time. Thanks. Bye.